Welcome back, student. Today we are going to see the identities of regular expression and Arden's theorem. Okay. So in the last class we saw the regular expression. When we will say the regular expression, we saw that. Again, we saw some of the example also, and this identities of regular expression is very important. If you go for the PG set or GATE, there directly the question come from the identities of regular expression. Okay, and we will see one theorem, Arden's theorem, in today's class. Okay, so here identities related to regular expression is, here give R, P, L, Q as regular expression. The following identities hold. Phi star, every time whenever you are getting the phi star, then you will get the epsilon. This is a identity. Whenever you will get like this, the answer will be epsilon. Epsilon star also is a epsilon. And whenever you will get in the equation epsilon star, in place of that directly you can write the epsilon. In the next way, another one is R star, means regular expression star. Star is nothing but closure, is equals to, you can write R closure R. Whenever you will get equation like this in the equation or in the problem, in the string, if you get like this, then you can use R closure R. Okay, so here in this identity here, R star, whenever you will get R star in any equation or any string, okay, in that time you can write only one R star. Okay, so this is like a formulas. We can substitute the value R star, in place of this you can write only R star. Okay, next is R star, means R closure of whole closure. So what we can write? We can write the R closure. Okay, so this is star closure, already we have learned. Keen closure, that is a closure. Okay, R closure. Regular means this is R means regular expression. R closure R. Okay, this is 2 is repeated, this RR and this RR is repeated. Fine. PQ closure P is equals to P of QP closure. Whenever we have like this PQ closure and P, so in place of that you can write P of Q P closure. You can write in reverse direction, means whenever we will have this kind of equation you can write like this. Okay, next one is A plus B, A union B is closure, is equals to A closure, B closure and whole closure, is equals to, so you can write whenever you have like this, you can write this, A closure union B closure whole closure, or A plus B whole A plus B closure whole closure, or you can write A closure B A closure and whole closure. So you can write whenever we have this equation. I will show you the example, then you can easily identify what is this. Okay, regular expression plus phi or phi plus R, regular expression, you can write R, the identity of union. This is plus is union. Okay, fine. Next, R intersection or concatenation, R epsilon or epsilon R, you can write regular expression, the identity for concatenation. Okay, or you can write dot, or you no need to write dot. Fine. Another one is phi L, L is the language regular expression, is equals to L phi. The answer will be phi only. Okay, phi L or L phi. The answer will be phi only. Next, R plus R union R is R. Which law we will call? Idempotent law. Okay, this is a law. Whenever we have R plus R, in place of that you can write only R. Next, L of m plus n is equals to Lm plus Ln. This is called left distributive law. Means whenever we have Lm plus n, you can take like Lm union Ln. Okay, you can write like this. And what is this law? This is called left distributive law. Next, m plus n of L means ml plus nl. This is right distributive law, and this is left distributive law. If the bracket is first parenthesis, then this is a right. If parenthesis after or later, then that is a left. So epsilon RR closure is epsilon plus R closure R. You can write R closure. In what is this? In R closure you can add the epsilon. Okay, so whenever we have this equation, in this place just you can write only R star. So this is the identity related to regular expression. So this is important, helpful for you for the further when we solve the expression and solve the problems. Okay, so this is Andrews theorem. In this Andrews theorem, what is Andrews theorem means? If P and Q are two regular expression over, and if P does not contain them, the following equation in R given by R is equals to Q plus RP has an unique solution, that is R is equals to QP closure. What it is telling, whenever you take this equation, okay, whenever you take this equation, in this equation you will get the unique solution, that is R is equals to QP star. That means whenever we get any equation in the form of R is equals to Q plus RP, whenever we get the equation in the form of R is equals to Q plus RP, then we can directly replace by R is equals to QP closure. So here first we will prove that R is equals to QP is a solution of the equation, and then we will also prove that it is the unique solution of this equation. So we will prove this equation and this equation. With the help of this equation we will get this solution. Okay, let's see here. So here I am taking this one. What is this? R is equals to Q plus RP. So first thing, I am implementing wherever the R is there, I am implementing this. R is equals to QP closure. QP closure. Okay, I am implementing wherever this R is there, I am implementing this equation. Okay, this. Fine. Let's see. Start. R is equals to Q plus, in place of this R I am writing this one. Okay, in place of that I am writing R, sorry, in place of that I am writing Q P closure, QP closure, okay, and QP closure. When we finish this R, then we will move to next P. Okay, So this is our equation 1. In the equation 1 we implemented RP. Okay, so this is the thing we implemented. I will erase this P for easily identification. What is a new part is here. So QP I got from here. Next one, R is equals to okay. Now I am taking the common thing here. I am taking common is Q. Okay, I am taking common is Q. I am taking as a common. Okay, so what I left here, epsilon empty, plus I have taken Q here. So what is remaining? P closure and P. This is we got. Okay, now as per the identities, when epsilon plus P star means take R star, R, so you can write R star R, you can write R star means closure. Okay, you can write closure. So in place of this you can write the R star. R star means what we have here? We have here P. So here R is equals to Q, and this whole will written as P star. Okay, so this is we prove R is equals to QP star, we proved. Okay, here R closure R, because of that we are taking R closure. Here P closure P, because of that we are taking P closure. Okay, so this is proof. Now we need to see the next one. By itself can we get the solution? Let's see. Next, here R is equals to Q plus RP. Okay, this is this equation. I taken. Now I will do one thing. In place of this R, I will add all this. Let's see. R is equals to Q plus, instead of R, I am going to write this whole equation, this equation only. So how can I write? I can write, I will use this pen, Q plus RP, I want to write this full, Q plus RP, and now just in place of this R we have written this, so one more P is here, this P is here. In place of R we have written this one. Okay, this is equation 1, we got it. Next again we have a R, so R Q plus Q, sorry, we have the R, but first we will open this. Okay, sorry for this. So here first we will open QP. Okay, what is this? QP plus RPP means RP square. So I got it this. Next, again we have R. Let's do it. R is equals to Q plus QP plus in place of this r, again I need to write this whole. So how to write? Bracket. So I will use another pen. Q plus rp bracket close. In place of this r, I have written this one, q plus rp, okay, q plus rp, and what is remaining here? P square. P square is remaining. So here P square is remaining. Next one is r is equals to, I need to open this, q plus qp plus here qp square, I will, okay, qp square plus rp into p square. So what the answer? rp cube, rp cube. Like that you will get so on, okay. So at the end, what the answer you will get? At the end you will get r is equals to q plus qp plus qp to the power of n, q to the power of n plus rp to the power of n plus 1. Why I am writing n plus 1? Means, can you see this q, qp, okay, qp to the power of n, n means 2, plus can you see this rp to the power of 3, 3 means whatever the n value, that is plus 1. So because of that, rp to the power of n plus 1. So this is, at the end we will get this equation. Now we have the r again. So this r, again use this one, okay, again use this one instead of r, in place of r. So here r is equals to, so here I will write here what I am going to do here. Okay, in place of r, if you implement this, after implementing this we got this answer. But if you go to the identity, in the identity if we have the r, we can write r is equals to qp star. In place of r you can write qp star. Clear? Okay, next, the next is r is equals to q plus qp plus qp2 plus so on qpn, okay, qpn, here that should be a dots, qpn plus qp star. I will do one thing, I will use black. In place of this r, I am writing qp star, and this p power n plus 1, p power n plus 1. So what is a black color? That means just I am replacing here, the rest of the thing is same. Next is here, can you see q, qp square, so on, qp to the power of n, qp star p. So here in every in this equation you can take out the q is a common, I am taking q is a common. if we remove the q, this is a empty string epsilon plus here p plus here p square plus so on p to the power of n plus you have taken this q also. So, what the answer will get? P closure, okay, and p to the power of n plus 1. So, we will get this equation, okay. So, here if you see here p square, p cube, so on, p to the power of n plus p to the power of star. So, in place of this you can write what is this? Epsilon with the increasing, that means it should be, this is a closure. So, we can write p closure. P closure, when you write including the epsilon, it will return the value. So, this is a q. In place of this we can write the p star. So, this is p star, this is r is equals to qp star, r is equals to qp star. So, this is a answer we got. We have proved here, okay, and we proved here also. Fine. So, this is about the Arden's theorem, okay. Arden's theorem, this is a unique r is equals to q plus rp. Whenever we get any kind of equation in this similar format, then directly you can write the r is equals to qp, okay. Directly you can write r is equals to qp. Fine. So, this is the thing about this Arden's theorem. I hope you understand. In today's class we completed the identity of regular expression as well as we completed the Arden's theorem. In the next class I will show you the regular expression example. We will do some of the example of regular expression, then we will move to the finite automata with output. Then our first unit will going to be complete in next 2-3 classes, okay. Thank you very much. This is today's lesson. Thank you.